The Megacity Logistics Lab is a research initiative at the MIT Center for Transportation and Logistics that is focusing on understanding better the freight and logistics movements of megacities. Megacities are the urban areas of more than 10 million people. These urban areas are new in the history of humanity as a whole. Since 1950, the rate of urbanization has been much faster around the world. We used to have a couple of large cities of over 5 million people around that time in Japan and Europe. And now in 2000 we have over 20 megacities, most of them in the developing world. These megacities are projected to reach close to 60 or 70 of those urban areas in the next 30 to 40 years. And the need of goods and logistics in those cities is only going to continue to increase as urban dwellers have more income. They also need to provide basic services and goods, and all of those need to be supported by a robust logistics system. Unfortunately, most both urban planners and even logistics professionals are not really used to think of urban areas as a domain they need to understand from a freight perspective. And the Megacity Logistics Lab is trying to help not only collect data and identify better what the problems are, but also try to develop solutions for the future of urbanization from the perspective of move of goods and products. Since these megacities are fairly new, one of the problems that we have observed is that there is not enough information about the interaction between logistics and the actual urban form. So what we decided to do this summer was to work on with a series of partners around the world to collect this information. And this information includes not only understanding how the stores are laid out in a square kilometer, but also be able to completely document and describe how the logistics system interacts with those stores in that square kilometer. And that's where KM2, one of the platforms, came to life. We needed a way to, after we collect this data, be able to put it in a central repository that will then be used to compare and learn from different urban structures around the world. And this data will be freely available, and we plan to continue collecting it for the future. At the same time, not only is the lack of information on the city level, also companies that operate in the urban area need to have a better way to explore and understand how their customers are ordering and how the overall pattern of consumption is going in a city. And that's where the other side of the equation and of the project that we did this summer come and play an important role, and that is Loopa. Loopa will allow to collect vast amounts of data, of activity data of one company, and will provide a platform that allows for that company or any other one interested in understanding how goods move into the city to create a standard way to describe the demand and explore at the square kilometer level how their clients are ordering, and then compare that on potential opportunities for improvement of their logistics system.
The main goal of KM2 is to display key information of a square kilometer in different megacities around the world. Using this information, you can easily understand the behavior of freight activity in a particular city.
The selection of the key information and the format creation was the first step towards building the project. The most relevant information categories were selected. These are shop inventory, roads and regulations, traffic count, delivery tracking, and disruptive violations. A group of MIT students went to different megacities around the world to collect this information. The cities in this first stage are Madrid, Mexico City, Beijing, Kuala Lumpur, Santiago, Chile, Sao Paulo, Rio de Janeiro, and Bogota. The data collection schedule includes 3 days of full inventory of shops, roads and regulations, and contextual observations. The remaining data was collected on a block that represented the most significant portion of freight and activities in the square kilometer.
KM2 was developed from scratch. First, we programmed a CMS that allowed the collection team to upload their information in our database. Next, we built an API to get the visualization data in a JSON format. Finally, we created the final dashboard and showed the information as a set of interactive charts and map visualization. The system works on all browsers and in almost all versions. You can even access data from a tablet device and get an enhanced touch experience.
The goal of Loopa is to visualize key indicators of the logistics operation of a company displayed over the geographical area in which it operates. This is done to easily display this information and show over a map the key areas depending on different variables, such as the concentration of customers or the income they represent. In order to display the information geographically, the area covered by the information was divided into square kilometer quadrants.
Each square kilometer groups information and displays it in the platform. The data processing was done also using the identifiers created for each quadrant. Some of the data users can visualize is customers and products per square kilometer per month, customers and products per square kilometer per week, customers and products ABC classification to reflect their behavior. The numeric information is presented also through graphs and a smaller version of the map, displaying the exact location of each customer and providing a better sense of the area that is being observed.
We built Loopa using the latest web technologies such as HTML5, CSS3, and pure JavaScript. With the aid of D3, a data-driven framework, we managed to develop a really nice user interface so that the users can make most out of their data.
Both KM2 and Loopa were designed with a minimalist style, always keeping in mind to facilitate users' browsing experience. The display of charts and maps start to be as clear as possible, so that people outside the project can understand at first glance the behavior of the data. Because humans have a better absorption of information through visual elements, we use iconography that allows to transmit a complex concept through a simple image.
So these two platforms that we have developed in collaboration with students from the Monterey Tech, KM2 and Loopa, are actually the foundation of a much larger and ambitious project that we have at the Megacity Logistics Lab. We are this data collection effort and this primary research is ongoing in multiple cities around the world. And these two platforms are going to be the basis for all our future data collection. And we hope to not only grow the data, but also enhance the applications. And we expect others to contribute to these platforms and so they can be used to plan better cities, and also for companies to be able to operate more efficiently in very complex cities in the emerging world.